Alright, ladies and gents, day 3, talking about natural log and the number e. So the number e, famous irrational numbers, one of the most important numbers in math. We use it with our natural log. First few digits, 2.7182, so on and so forth. You can read it. Right? So our number e is what we call our natural base. Right, if you want to look at its graph, you can. We're not going to worry about it too much, but any log that has a base of e is what we call the natural log. Right? It's written as ln of x. So log base e is the same as ln of x. Now, when we're writing it in log form, it's y equals the natural log of x, or if it's easier to remember it, y equals log base e of x. The really important thing to remember here though, if you write it as log base e in the test, it will get marked wrong. Every log base e should be changed to the natural log, or ln of x. So if I change to exponential form, it becomes e to the y power equals x. Right? Just like changing from log to exponential we have been, or exponential to log, should be the exact same, except now we have a base of e instead of just a normal number. On our calculators, we already have a really nifty button on your calculator. If you get your calculator out, you should be able to look on it right underneath your log button. Should be an ln button. So if we're trying to evaluate things, such as a natural log of 17, I did ln 17, hit enter. Down into 3 decimal spots, probably about 2.833. Right? Same thing for the natural log of 2. ln 2, 0.693. So if I go on here, what did I say? 2.833, 0.693. So your ln button, your natural log button, is right underneath the common log button. If we're trying to put something with an e into our calculator, you hit second ln, it should pop up e, and you can put whatever type of exponent you want there. In our case, we're going to do e to the 3rd power. We get 20.086. And we're going to do e to the negative 2/3 power. So second natural log, negative 2 divided by 3. We should get 0.513. So if you look, like I said, if you look at your calculator, you should be able to put natural log in it. You should be able to put e to whatever power you want in it. That'll really help us here in 2 seconds when we try and solve with our natural log. So, like I said, solving using e and ln. It's the same exact rules as when we solve with logs. We need to isolate our log, which in both of these cases, it's already isolated. So we're going to isolate our log. Then we're going to switch it to exponential form. If it is easier for you to switch it from log to exponential with the natural log as log base e of x plus 5 equals 6, go ahead and do that. Right? Then we can switch it to base of my logs, base of my exponent. So e to the 6th power equals x plus 5. Well, to solve that for x, I'm going to subtract 5 from both sides. So when I go to my calculator, I do second natural log, e to the 6th, enter, minus 5, enter. Should give me about 398.43 if you round to the nearest hundredth. Alright, I'm not going to put any more in my calculator. I think you guys get the gist of it. You can put it in your own calculators though. So, second one. Natural log of 3x minus 4 equals 1.3. Same thing, if you need to make it log base e to help you change it to exponential form, do that. So I get log base e of 3x minus 4 equals 1.3. E to the 1.3 power equals 3x minus 4. Well, go ahead and solve for x. Add 4 to both sides. E to the 1.3 power plus 4 equals 3x. Then I can take and divide by 3 on both sides. So in your calculator, put e to the 1.3 power, enter, plus 4, enter, divide by 3, enter. We should get x is approximately 2.56. Alright, couple going the other way, where we're given e, we're given it in exponential form. Guys, like I said today, if you're given it in log form, you're staring at a log, you have to switch it to an exponent. We just did that. If you're staring at an exponent, you have to switch it to a log. So isolate our exponential first, right? E to 3x equals 15. It's isolated. Switch it to log form. Log base e of 15 equals 3x. Well, log base e is the same as the natural log. So ln of 15 equals 3x. And I know to solve, I'm just going to divide by 3 on both sides. Well, in your calculator, type in natural log 15, enter, and divide by 3, right? Natural log 15, enter, then divide by 3. We should get approximately 0.91, or 0.90, excuse me. Approximately 0.90. Awesome. Same thing for the next one. E to the 2x minus 6 equals 20. Change it to log form. Log base e of 20 equals 2x minus 6. Well, log base e is the same as the natural log of 20. Equals 2x minus 6. And then just solve for x. Add 6. Be careful though. The natural log of 20 is by itself. Plus 6 equals 2x. If you do 20 plus 6, you mess up your whole answer. So don't do that. And then divide by 2. So in your calculator, you should put natural log of 20. Hit enter. Plus 6. Hit enter. Divide by 2. Enter. You should get x is approximately 4.50. So solving using natural log and e, same as solving using a normal log. Alright, then compound interest. So last unit we talked about compound interest. We used this formula, a equals p times 1 plus r over n to the n times t power. Awesome. If it says compounded continuously, we have a new formula. A equals p times e to the rt power. So compound continuously. We invest $2,000 in an account that pays 1.5% annual interest, compounded continuously. So I know I'm using my new formula. My original amount, my principal, is $2,000. My rate, 0.015, right? 1.5% as a decimal. And how much money do I have in 3 years? So t equals 3. So if I plug this into my new formula, I get a equals 2,000. Times e to the 0.015 times t power, or times 3 power. And I can plug this whole thing into my calculator right away. So I go to it, 2,000 times e to the 0.015 power times 3 equals, we should get about $2,092.06. A is approximately $2,092.06. Pretty simple. We're just using a new formula which, if you need it on a test, will be given to you. A equals our principal times e to the rate times time power. Alright, next one. Talking about investing $5,000 at 3.6% for 10 years. Right? Our principal, $5,000. Our rate, 0.036. Our time, 10 years. We have 3 different scenarios: compounded quarterly, monthly, continuously. The first 2 use that old formula. A equals P, which is 5,000, times 1 plus my rate over the number of times I'm compounding, which in this case quarterly would be 4. So over 4 to the rate times time power, or excuse me, the n times t power. So 4 times 10 power. And you go ahead and you just punch that whole thing in your calculator, just chugging numbers in. We should get approximately $7,155.12. We have the same formula for part B, except the only thing that's changing is n now equals 12 because it's compounded monthly. So A equals 5,000 times 1 plus 0.036 over 12 to the 12 times 10 power, right? Plug and chug, just plug your numbers in. Then we can punch that into our calculator as well. We should get approximately $7,162.79. Last one for this problem, compound continuously. This is where it's going to change. Right, we're going to use our new formula, P times e to the RT power. Well, A equals P, which is 5,000, times e to the rate, which is 0.36, times time power, times 10. Once again, plug and chug. Just plug your numbers in, plug it into your calculator. You should get approximately $7,166.65. And we can see which is the best deal. Obviously, compounded continuously. It keeps compounding, we earn more money on it. Compound continuously will always be the best deal. Alright, one last problem. We invest $6,000 in account, pays 3.5% interest, compounded continuously. So I know I'm using my new formula. How long will it take for the balance to be $10,000? Well, my principal, I'm starting with $6,000. My rate, 0.035. I want it to be 10,000, right? My A value is 10,000. And my time is my variable here. I don't know what my time is. That's what I'm looking for. So if I plug these all into the formula, I get 10,000 equals 6,000 times e to the 0.35 x power, right? X, I don't have that term. My t is my variable. Just like with any other thing we're trying to solve for x, we got to get that exponential part by itself. So I'm dividing by 6,000 on both sides. 10,000 divided by 6,000 gives me a repeated decimal. So I'm just going to reduce my fraction as much as possible, which ends up being 5/3, equal to e to 0.035 x power. I'm looking at an exponential. To solve it, I need to switch to a log. I've said it 15 times now. We take our exponential, switch it to a log. Log base e of 5/3 equals 0.35x, 0.035, excuse me, x. And then I know to solve, all I'm going to do, divide by 0.035 on both sides. Right? Log base e, the same as the natural log. Oops. Natural log of 5/3 over 0.035. That should equal x, so you plug that in your calculator. Natural log of 5/3, enter. Divided by 0.035, enter. X should come out to approximately 14.6 years. That's it. That's all you got for today. So now, look back on your notes, do the homework sheet, reassessing tomorrow. Alright, so be ready to reassess.